Okay, some of you have asked me to go over U sub back sub and review that, so I just want to use some of the same examples that we had before because these don't come up that often, and if you want to follow along in your old notes, you can. The general idea was this is your last resort. You have tried to see if it's a basic rule, which obviously this is not. You have tried regular U substitution and you get stuck. And so that leaves you with U sub back sub as your last opportunity to get this right. So again, you're going to go through some similar steps as U sub. You're going to pick a U, and in this case it would be the denominator. So 1 plus the square root of x. And instead of taking the derivative at this point, the only change you're going to make here is you're going to solve it for x. So I'm going to subtract 1. Then I'm going to square both sides, and I'm squaring this whole side, so I need to put it in parentheses. And once you have the x solved for, then you do the derivative. So this will be a chain rule. 2u minus 1 to the 1, understood? Then the derivative of the inside would be du dx. Over here, the derivative of x is 1. Again, I want to multiply by the dx like I do in regular U sub. So I get 2 times u minus 1 du equals dx. So what happens now is substitution. Since this all equals dx, I'm going to take this dx out, and I'm going to put all that in. So I'm going to need some space. Instead of putting the 2 over here, I'm going to move it to the front so that I remember to bring it down, but that it doesn't confuse me. So I have u minus 1 du in for that dx. Then when you look at your original problem, this is your u. So this is really 1 over u. And now that you have everything, you want to make it look prettier. Take out some of that space, but distribute this in and make a polynomial looking thing. It's not really a polynomial because you have fractions, but polynomial look. So 1 over u times u. The u's are going to cancel, so that's going to leave you with 1. 1 over u times negative 1 would be 1 over u. And make sure to use your notation correctly. Then you should be able to take the antiderivatives of what you have. If at this point you still have x's, then you've messed something up. You've chosen a bad u. Alright, I'm going to take the antiderivative of 1, which would be u, and the antiderivative of 1 over u, which would be the natural log of the absolute value of u. And I want to make sure to put my plus c. The final step is to plug back in your u's. So I'm going to plug in 1 plus the square root of x minus the natural log, the absolute value, 1 plus the square root of x. You could distribute the 2 if you needed to. You can actually even take away the absolute value bars here because 1 plus the square root of x, if you think about your square root of x toolbox function, it's always going to be positive. And so 1 plus a positive will be positive, and you don't need the absolute value bars. So this is the first example. Okay, here we have another example that is a U sub back sub because it's not a rule. And it's not a regular U sub because you would get stuck. So we're going to come over here and pick our u to be 1 plus the square root of x. And again, the step is different here just because you solve for x. So u minus 1 equals the square root of x. Square both sides. And then take your derivative. So again, on this side, pretty much the same as last time. You've got a chain rule. Times du dx, and then here the derivative of x is 1. So in this case, need to come over here and multiply by my dx. Okay, so in this case, I want to take out this dx, and I want to put all this in. So integral du, I'm going to put the 2 out front, and the u minus 1 in. Then I have not taken care of this. This is where I got my u from, but it was under a square root. So instead of a square root, I'm going to write a 1/2 power. And then I'm going to distribute in. Make sure to bring down that 2 on the outside. And then I have u to the 1/2 times u, so that will be to the first power. I'm going to add those exponents and get 3/2 power. And then u to the 1/2 times -1 will be u to the 1/2. Then I want to take, I'm going to bring my 2 down again. I'm going to take my antiderivative by the power rule. So I'm going to add 1 to the power, making it 5/2. Divide by that in front makes it flip and multiply to 2/5. And then the same thing here. Add 1 to the 1/2, it becomes 3/2. Then when I divide by it in front, I have to flip it and multiply, which makes it 2/3. And then the last step would be to plug the u back in. So again, u is 1 plus the square root of x. Here it's to the 5/2 power. Here it is to the 3/2 power. Now, if this were a multiple choice question, they may have distributed the 2 in with these fractions here. 2/5 and 2/3 would become 4/5 and 4/3. Okay, the last one I'm going to do has a more classic look for this type of problem. It's a u sub back sub. It almost looks like you could do a regular u sub, but if you get into the powers, they don't work out quite right. As you know, when you do a regular u sub, you're looking for a power that goes down in the problem, like if this were an x squared. Sorry, it's all supposed to be under there. If that were an x squared, this would be an x, and that would be, an indicator. However, the 7 would be a problem in this situation. But it looks really similar to what we would normally do, maybe a u sub ohm. It just doesn't quite get the details in there. We get stuck. You get some stuff extra when you try to do a u sub. So I'm going to come over here. I'm going to use this as my u, because under radicals is hard to get to otherwise. And I'm going to make u 3 minus 2x. Again, solve for x. So u minus 3 is -2x. And then divide by -2. When I do that, I'm going to do each one so that it's a linear look. So I get a -1/2 u and then a positive 3/2, because that's going to be easier to take the derivative of. Now I take the derivative. So I bring down the -1/2. I have du dx. The derivative of 3/2 is 0, and the derivative of x is 1. Multiply by dx on both sides. And now I'm ready to substitute. So since this equals dx, I'm going to plug in the -1/2 du. So I'm going to put the -1/2 out front and the du in the back. This is what I chose as my u, so that is going to be u to the 1/3 power. It's easier to work in a power when I'm trying to take an antiderivative. But I have this x plus 7 that didn't go away anywhere. So this is a little different than the first two problems because I'm going to have to plug in something for x. That is where this line becomes important. I am going to plug all this stuff in for this x. So I'm going to have -1/2 u plus 3/2 in for x. I still have to bring down the plus 7. Now, before I go on, I need to combine the 3/2 and the 7. And that will be 17/2, because 7 is 14/2. And now it's pretty much like the other problems. I'm going to distribute this u to the 1/3 in, add the powers. So I have a -1/2 u to the 1 plus 1/3, so that'll be 4/3, and then plus 17/2 u to the 1/3. Now I'm going to bring down my negative 1/2 from the front, and I'm going to take the antiderivative. So bring down the negative 1/2, add 1 to the power, I get 7/3, multiply by 3/7 in the front, bring down the 17/2, add 1 to the power, I'm going to get 4/3, multiply by 3/4 in the front, and then don't forget my plus c. Now, you're probably not going to see this. You're going to see the simplified version. So you want to make sure that you can multiply those correctly. If you multiply the negative 1/2 and the 3/7, you get the negative 3/14. And then if you multiply the 17/2 and the 3/4, you get 51/8. Now, I'm out of room, but our last step is to plug back in for u. So just make sure that you take what you have as your u and you plug it back in here and here before you finish.